Kinetics. One thing I did obviously, I don't know if I have a look right now, I didn't really emphasize is the Maxwell-Boltzmann distribution curve, but I think that is honestly that is easy. You just need to memorize what it looks like when you increase temperature, normal temperature. That's it. Obviously, I don't want to like just make unnecessarily like 1, 2, 3, 4, 5, 6, 7 flashcards. Like you should be confident with Maxwell-Boltzmann distribution curve right now. The only thing I think students struggle with, which I did as well, and my teachers found in our mocks, we struggle with a lot, is what happens when you increase temperature. It shifts slightly, it goes lower and it shifts slightly to right. I think that will definitely come up. So I would just memorize that. Apart from that, these flashcards should be pretty good. So define reaction rate, the change in concentration of reactant or product over time. Amount of time a product formed / reactant used over time. Two key conditions for particles to react. They must collide in the right direction, and they collide with at least a minimum amount of kinetic energy. This is known as the activation energy. Now, enthalpy profile diagrams, I don't know if it's on the spec. I'm going to have a quick look. So this is, I'll show you guys as well. So this is what you do. Kinetics right here. This is definitely on paper 1. So, yep. Study enables kinetics to determine whether single reactivity. Okay, sure. Reactions only occur. Yep. Sufficient energy collide in the same direction. Define this. Explain why most collisions do not lead to reaction. You just talk about how not enough energy, and they're probably not colliding in the right direction. Maxwell-Boltzmann distribution curve. Again, I showed you that. Draw and interpret distribution curves. Perfect. Meaning of the term rate of reaction. Yes, reaction rate. And use the Maxwell distribution curve. Explain why a small temperature increase can lead to a large increase in rate. Should investigate the effect of temperature, sodium thiosulfate, hydrochloric acid, initial rates method. Again, that's practical. That will be in my separate playlist. Investigate our knowledge and understanding of the factors effect have changed methods of storage and cooking food. That's just some weird application, nothing you need to memorize. And then effect of this. It does also say use Maxwell-Boltzmann distribution curve to explain how catalysts increase through a reaction involving a gas. Now, if I go back through kinetics, yes. So I actually think you do need to memorize the enthalpy profile diagrams because it says how catalysts increase through a reaction. Use a distribution. Use the Maxwell-Boltzmann curve. Yeah. Yeah, so you do unfortunately need to know that. It's fine. I'm not going to memorize it, but I'll probably memorize the day before. So bonds are stripped there. Enthalpy, progress, reaction, reactants, products, energy barrier particles have to overcome. Activation energy, bonds break, particles have enough energy. But what is this? Enthalpy profile diagram for activation energy. That was not the same diagram that was in the textbook, was it? Yeah, that's not in the specification, no. What's on the specification is Maxwell-Boltzmann distribution curve. Yes, well that's the enthalpy profile diagram. And draw and distribute different distribution curves for different temperatures. Maxwell-Boltzmann distribution curve, high temperature, low temperature. And then explain how catalyst increasing it. This is no indication of catalyst, so this needs to go. Define Maxwell-Boltzmann distribution. A graph of the number of molecules in the gas with different kinetic energies. I'm going to keep it because why not? Just helps you with the overall understanding of what it actually is. Molecules in the gas with different kinetic energies. Shape, when you increase temperature, remember it goes a bit down, shift to the right. They would never ask you to explain what happens. They would just say, just draw it. So you don't need to, you just need to memorize what happens basically. Bit down, shift to the right. Push it over to the right, yes. Why is increased temperature increased rate? Because increasing more kinetic energy collide more often, greater proportion of molecules have energy greater than equal to the activation energy. Okay, let me get rid of this. No. Increased concentration, increased rate of reaction, particles more close together, collide more often. So more collisions. Yep, more chance to react. Increased pressure, close together, collide more often, more frequent collisions. Draw the energy profile for Maxwell-Boltzmann distribution. Yes, this one you do need to, because it will show you the activation energy without catalyst, activation energy with the catalyst. It shows you how the peak goes a bit down. This one you do need to memorize, that one. But the other one you don't. Define dynamic equilibrium. Dynamic equilibrium, at equilibrium, the concentration of reactants and products stay constant. Okay, the concentration of reactants and products stay constant, and dynamic equilibrium can only happen in a closed system. The Chatelier's principle: if a reaction at equilibrium is subjected to a change in concentration, temperature, or pressure, position of equilibrium moves to counteract the change. Homogeneous equilibria, or a reaction where every species is in the same physical state. What happens if increased concentration of reactants with increased concentration of product? If you increase the concentration of a reactant, well, equilibrium is going to shift to the right hand side to oppose the increased concentration of reactant, hence decrease concentration of reactant, increasing the amount of product. And same thing with the increased concentration of product, it moves to the left hand side to remove extra product. Okay, not too bad. Oxidation and reduction. Oxidation is the loss of electrons, reduction is the gain of electrons. Redox reaction when oxidation and reduction happen simultaneously. You have to say that word, simultaneously. Very, very important. Oxidizing agent, electron donor. Oxidizing agent, electron acceptor, and gets reduced in the mark scheme with these AQA mark scheme. It just wants you to say electron acceptor, so you could just say oxidizing agent, electron acceptor, reducing agent, electron donor. So with this topic, I think the hardest part is the energy profile diagram for the Maxwell-Boltzmann distribution curve.